So today what we're going to work on is partial fractions with repeat linear factors. So I would like you to put me on pause, try this, and then come back and check your answer. Okay, so notice that the denominators are x plus 3, x minus 1, and I have an x minus 1 squared, which means that in this denominator I have x minus 1 times x minus 1. So I need to multiply the first fraction, which has a denominator of just x plus 3. I need to multiply that by x minus 1 times x minus 1. Now in the numerator, I'm going to multiply that out because it's going to be 2 times that. So x minus 1 times x minus 1 is x squared minus 2x plus 1. The middle fraction here, I have an x minus 1, but I need another x minus 1, and I need an x plus 3. So I'm going to multiply by x plus 3 and an x minus 1. And in the numerator, so I'm just going to multiply that out. That's going to be x squared plus 2x minus 3. And the last fraction, I have the x minus 1, x minus 1. What it's missing is the x plus 3. So I'm going to multiply by x plus 3. Okay, so let's distribute in the numerator. So in the numerator, I will get 2x squared. So I'm working with this part here. So I'll get 2x squared minus 4x plus 1. So 2x squared minus 4x plus 2. And then I'm going to distribute the negative 1. So it's negative 1x squared minus 2x plus 3. And then I'm going to distribute the 4, which is 4x plus 12. And that would be all over x plus 3 times x minus 1 squared. And then when I combine all my like terms in the numerator, so in the numerator I have the 2x squared minus 1x squared is x squared. Negative 4x minus 2x is negative 6x plus 4x is minus 2x. 2 plus 3 is 5 plus 12 is 17. All over x plus 3 and x minus 1 squared. Okay, so what we're going to be doing is working with coming up with the fractions when I have a denominator that has the same repeated linear factor. So like this has here, I have this linear factor of x minus 1, I have 2 of them. So when you have 2 of them, what you're going to do is you're going to set up your fractions, and you're going to have to set up the fraction with the denominator of the linear factor, and you're going to have to set up a fraction with the denominators of linear factor squared. So let's take a look at the first one. So I have x plus 5 over x minus 2 squared. So I'm going to set up my fractions. So I have the same linear factor x plus 2 and it's squared. So I'm going to have one of my denominators just going to be that linear factor of x plus 2. And then my other denominator is going to be the x plus 2 squared. I just can't have x plus 2 and an x plus 2. I can't have this x plus 2 and an x plus 2. Because then my denominator is just x plus 2. So I have to have that square. So I have to have one as x plus 2 and then the other one as x plus 2 squared. Okay, so in the numerator here I'll have an a, and in the numerator here I will have a b. So this denominator here, in order for it to be the same as this, I need to multiply this denominator by x plus 2. Because we have 2 of them. And multiply that in the numerator. X plus 2. So I have x plus 5 over x plus 2 squared equals, I'm going to distribute my a. So I have ax plus 2a plus b all over x plus 2 squared. All right, so I can now not worry about the denominators here, right? So I know my numerator, since my denominators are equal, I just have to get my numerators to be equal. So then I know this, x plus 5 has to equal ax plus 2a plus b. So I'm going to take my x and set it equal to just, I only have one that has an x, so it's x is equal to ax. And then I'm going to take my 5 and set it equal to the ones that don't have the x. So it's 5 is equal to 2 plus b. All right, so the top one here, since they both have an x, I could get rid of the x. But remember, there really is a 1 here. So that's 1 is equal to a. And then I still have this one here. 5 is equal to 2a plus b. So now since I have a is equal to 1, I could plug that in for a here. 5 is equal to 2 times 1 plus b. Subtract 2 from both sides, b is equal to 3. So now I have my fraction. So it's going to be a over x plus 2. My a is 1, so it's 1 over x plus 2. And it's going to be b plus b, which is 3 over x plus 2 squared. So that would be my answer here. Okay, so let's flip it over and try the one on the back. Okay, so for the second example, I have 8x squared plus 33x plus 49 over x plus 4 times x plus 1 squared. Okay, so let's start this off by setting up a fraction for the denominator of x plus 4. All right, so for the x plus 1 squared, I need a denominator for just x plus 1. And then I need a denominator for the x plus 1 squared. All right, so I'm going to have an a, a b, and a c here. All right, so to make all the denominators the same, I'm going to have to multiply the last one by x plus 4. The middle one, I'm going to have to multiply by x plus 1 and then x plus 4. So in the numerator, I'm going to multiply that out. So that's going to be x squared plus 5x plus 4 when I multiply those binomials out. And the first fraction actually, not the last fraction, the first fraction, I am going to multiply by, x plus 1 times x plus 1. So in the numerator, that's x squared plus 2x plus 1. Okay, so let's multiply that all out. Okay, so I have 8x squared plus 33x plus 49 over x plus 4 times x plus 1 squared equals, and now I'm going to distribute the a. So I have ax squared plus 2ax plus a. Distribute the b plus bx squared plus 5bx plus 4b plus cx plus 4c. All over x plus 4 times x plus 1 squared. Okay, so now I don't have to worry about the denominators. The denominators are the same here. So I have to worry about the numerators. So while I rewrite the numerators, I am going to rearrange them so that my x squareds are together, my x's, and my numbers that don't have any x's. All right, so I have 8x squared plus 33x plus 49 equals, I have ax squared plus bx squared plus 2ax plus 5bx plus cx plus a plus 4b plus 4c. Okay, so now I'm going to take my x squareds and set them equal to each other. So I have 8x squared equals ax squared plus bx squared. Take the x and set them equal. 33x equals 2ax plus 5bx plus cx. And my constant, 49 equals a plus 4b plus 4c. Okay, so for the x squared, I could get rid of all my x squared. So it's 8 equals a plus b. For my x's, I could get rid of the x's. Just going to rewrite that so they line up underneath one another. 8 equals a plus b. So for my x's, it'll be 33 equals 2a plus 5b plus c. And the last one would be 49 equals a plus 4b plus 4c. Okay, so now I need to solve this. So I'm going to take the first one here, the 8 equals a plus b, and I'm going to solve this for a. So I'm going to rewrite this as a equals minus b from both sides, 8 minus b. All right, so I just need to move everything up, so just give me a second. Okay, so now I have one of my equations is solved for a. So I'm going to take my a and plug it into this equation here for a, the second equation, the red equation, and for the blue equation. So I get two equations with two unknowns. So I'm just going to write it over here on the side. So I have 33 equals 2 times 8 minus b plus 5b plus c. So it's 33 equals 16 minus 2b plus 5b plus c. So I'm going to minus 16 from both sides. I get 17 equals negative 2b plus 5b is 3b plus c. And now I'm going to do the same thing for the blue equation. 49 equals, plug in a, which is 8 minus b, plus 4b plus 4c. So I'm going to minus 8 from both sides, and I get 41 equals, combine the b's, negative b plus 4b is 3b plus 4c. Okay, so now I'm going to use these two equations, and I'm going to solve them. So 17 equals 3b plus c, and 41 equals 3b plus 4c. So I'm going to multiply the top equation by negative 1, so I get a negative 3b. So that's negative 17 equals negative 3b minus c. And the bottom equation will stay the same. 41 equals 3b plus 4c. So I add them together. Negative 17 plus 41 is 24. equals 3c. So c is equal to 8. All right, so now I have a c value, and I'm going to plug that c value into one of these equations over here and find the b value. Just going to move everything up a little bit. Okay, so I'm going to plug 8, my c value, into the first equation. So 17 is equal to 3b plus 8. So minus 8 from both sides, 9 is equal to 3b. So b is equal to 3. So now I need to get my a value. So I'm going to plug it into that simple equation I had before, which was 8 is equal to a plus b. So I have 8 is equal to a plus 3. That's my b value. So a is equal to 5. Okay, so remember my fractions that I have up here. So my a is 5. So it's going to be 5 over x plus 4, plus b, which is 3 over x plus 1, plus c, which is 8 over x plus 1 squared. Okay, so that's my final answer. That is it, and we'll practice in class tomorrow. Have a good night.